I just finished filming last week's intro, so I am soaking wet from a water puddle. So obviously I'm not going to be talking about the high voltage right now. I'm going to pass it over to Keaton, our Chief Technology Officer, and he's going to go through some of the exciting updates, where we're at right now and what we're hoping to achieve.
Hey guys, like Chase just said, we're about to hit a huge milestone here. We have our PDU plugged in. We've completed our pre-charge test, so it's able to go from battery power all the way up to axle power. So now we're just doing some final comms tests that we're gonna send high voltage down these wires and spin some axles. Super exciting stuff. We'll let you know how it goes. Hey guys, so today is really exciting. We're finally trying to get our batteries into the undisclosed truck. So as you can see, we have 6 batteries laid out here. And a funny little thing eagle-eyed viewers will notice on the signage for them, that they all have a specific number. That's because the way our battery manufacturer handles the communication is that they daisy chain from one pack to the other. So they have to go in a specific order. Now what we have to do is we have to organize them first into their cell or the pack clusters. So 1 and 2 go together, 3 and 4 go together, 5 and 6 together. Those 2 packs in a cluster work together to get that nice nominal 614 volts. And then we put those 3 clusters in parallel to get that nice high charge and discharge current that we need. After we get them all organized in that, we'll lay them out as they will look in the truck on the floor, match them up with their harnesses, and then start putting them in one by one and wiring them up.
So these are the under cab battery brackets. Because we've moved the cab forward on top of the steer axle, we have some room underneath the bottom of the cab, between the cab and the steer axle. So we're going to put 2 of the 6 of our high voltage batteries in that space. And these are the brackets that we've made to accomplish that. So you can see on the bottom, we're going to put a single pack here and then have another aluminum plate on top that we're going to bolt the batteries to as an assembly on the ground, and then lift the assembly into the chassis of the vehicle right here. These brackets bolt to the bottom of the cross members. So you can see the 4 holes on the bottom of the brackets line up with 4 holes in the cross members. And so we just have to unbolt the cross member bolts, put the battery bracket in, bolt the cross member back together. Goal by the end of the day would be to have 2 of the 6 of our high voltage batteries installed and ready to be wired up.
Night shift cutie at the truck stop knows my name. Threw the candle in the midnight oil and lit up the honky-tonk highway. I see the sun come up, cause I ain't been to bed. Gonna have my name cut into a stone when I lay my head. No rest for the wicked, at least for a few hundred miles. I'm running wild, ride the lightning, run on empty in the ring of fire. Roll, sweet child, I'm running wild.
Oh, Eric, what did you just do?
I just installed a manual safety disconnect, or MSD fuse. And what this is a pack fuse. It's built actually into the battery. So you know that every single battery, if anything was to happen, a fuse like this will open the circuit and make sure that it's all safe. Every single battery has one of these.
So that means the high voltage is now live, right? To the combiner box.
It is. And that's why right now, these have a safety disconnect switch on them as well, and they're closed. Or this is technically open. So you're in a safe position, lockout, tag out.
Pretty nice and fast.
We connected all of our batteries that are paralleled to the combiner box. Right now there's a resistor inside of this, which is balancing all the cells to be in the same between all 3 packs. Why we did it this way is you get a bit more juice out of parallel packs. And if one pack essentially dies or gets damaged, you can cut that one out. You can still get back home with 2 packs or even a pack.
This is our power distribution unit, or PDU. It takes power from our battery balancing box and delivers it to the rest of the truck.
So what does a battery balancing box do?
Our battery balancing box allows service technicians to lock out high voltage. So you can flip our switch, throw a lock on here, and as you remove high voltage, we have a bunch of different packs and it'll actively keep them balanced. We've got resistors in there.
So if you
they've
lose a
been
pack,
sitting-
it keeps it balanced to the other packs, yeah.
And if they've been sitting for a little while and they have up to 30 volts difference, this will balance it, and then we can hook it up to the rest.
Which is one of the issues we did have on Topsy. One battery would get a little bit lower and cause issues, and you'd have to re-flash up. Now, and for all those people that do say, hey, that battery balancing box shouldn't be behind the tire. If you blow a steer tire, you're gonna take out all your high voltage lines. That's not the permanent home. It's just there right now for testing. It's gonna be located in the frame rails here. This is just a test period. Don't worry about that for now.
Absolutely. And the same goes for our PDU and all of our low voltage electrical. We have it laid out so we can do easy testing. We'll be moving this, and a bunch of other components into the cab once this is done. Over the past few days, we've mounted the batteries in the frame rails. We wired them all up and wired to our power distribution unit, or our PDU. Then we ran all the wires down the frame rails and into the MCs, the motor control units. And then we ran all 12 wires back to our 2 axles. The next step is to lift up the frame rails and test that we've added enough slack so at full extension, we're not putting any strain on the cables. These 2 units are 2 motor control units, or our MCUs. They take in DC power from our power distribution unit, that's these large cables, and turn it into AC, which is going to go to our axles. We've got 2 axles with 4 motors for a total of 4 sets of 3-phase or 12 wires going back here. We've done a bunch of cable management to run that back while keeping slack in the system.
And this is one of the cool things where, as we're building and designing, we're already learning better things. So on the new axles, they've actually got the motor control unit, because most of this box is pretty well empty. So they have the motor control units now located right at the axle. So we're not gonna have to run the wires. So now it's only gonna be these 2 wires running back for each axle rather than all of these wires coming up and over. So little things we learned even on this version of the hybrid that have already been improved. So if you think where Carl came from to Topsy, to this one is already a massive improvement for Topsy, to the next version where we can eliminate these boxes completely. It's pretty cool. All right, like Gail said, my job now is to come in here with a crane, grab them by the back of these frame rails. We're gonna run 2 slings down, we're gonna lift up. One of the things I'm really picky about is that there's enough slack. Now, you want enough slack that you can have this thing fully articulated. One of the reasons is, even though this thing has a neutral toe switch where you can press neutral, kick the axles into neutral, free tow it from the front by grabbing the front axle, I know that there's gonna be tow trucks that are gonna be nervous about towing this, and they're gonna wanna hook it up from the rear like you would normally do with a semi-truck, because you don't want to drop a drive shaft or unhook that to tow it. Normally you pick them up by the rear. So if somebody happens, they grab it by the rear and they don't throw a chain around it, there's going to be a maximum extent where those axles will hang down. The last thing I want is for those high voltage wires to pop up. So basically we're going to be simulating a tow truck lifting this thing up by the rear without putting a chain on it, making sure that we don't have those high voltage lines pull out. I can only see the rear, I can't see the front too, so I'm gonna go real slow, but if anything even gets close, yell stop. That's my maximum lifting weight. Okay, well, that went pretty good. We got her up, we got her all the way bottomed out, maximum extent on the bags, bottomed out on the shocks, which is as high as I'd pull. I pulled till I basically couldn't go anymore and I was about to lift the axles off the ground. And we have more than enough slack. If anything, we've got plenty extra. One of the things we need, because we have high voltage lines, is good cable management. So we wanted something, so we designed this. It basically goes around your high voltage or air lines, clips on, just secures them really well. But because I believe in right to repair, fixing your own things, I thought rather than just making these and then charging them as custom upsells. What we'd do is we designed it, we'd make it free for everybody online on Onshape. So you can just go to Onshape, grab your own, 3D print it, put it on your own. So if you break one of these, if you need extra ones, I'm not gonna upcharge you and sell you $50 connections. Just go get them for free online. Lee's gonna tell you exactly about how these work, how we designed them, what they do.
I just printed these little triple clamps here. I just want to test and see if it'll fit on our high voltage lines here. You can see there's quite a bit of a gap there. That's a little bit too much. So looks like it's about 0.71 inches. I'm right in the Onshape app here. I can go in, I can edit the variable for my hole size. I can change it, type 0.71, green check mark again, and just like that it's changed. So no notepad needed. It's automatically updated on my laptop upstairs. I can go ahead, print this, and we're going to try and do a stress test on it to see how it'll hold up. We're going to test it, see how it breaks, see where it breaks, and then we'll make some changes if need be. Baxter here is going to hit it with the impact. Let's see what it does. Oh, right away.
Holy.
Right away, we broke the top cap.
Keep on going.
Yeah, why not? Keep on going. See what happens.
That's quite a bit.
So it looks like our top cap is definitely the weak spot. The middle part was doing pretty good. Yeah. So we're gonna try and redesign it without the top cap, and we'll show you what that looks like. This would be more of a hand tight with a wrench, carefully, not with the Baxter mentality of just send her home with the impact. So we're here in Onshape. You can see the current design here. We have the steel bottom plate, the bottom cap, the middle, or the top cap, and then the top cap. We're gonna try and integrate this top cap into this bottom cap here, you can see. So first we'll hide this, and then we'll thicken the top up, 1/4 inch. That's probably don't need all that. We'll just do 1/8 of an inch. Then we'll start a sketch on this face, just like that. We'll transfer that. Well, actually, we're gonna start a sketch on this face. I think that'll be a little bit easier. We're gonna take this, do a line here, construction line between the center points of the circles. Then we're gonna do a center rectangle from between the two, just like that. We'll do 2 inches here for that dimension, 1/2 inch for that dimension. See, it auto-fills. It's super nice to work with. Now we're gonna start a sketch on this side. We'll project this onto our sketch plane. We'll project the corner piece, and we'll start drawing the outline of the top cap. So it comes down like that. We'll do about a 1/4 of an inch going down like that. And we'll do an angle up to the top. We'll switch it to the other side. Do the same thing here. So 5, and then up there. Now we'll extrude it, remove all the way through, just like that. Or we'll go through all. Doesn't really matter for this side, but let me switch to this side. See why it's important. Sketch here. There. So we're on this side now. We'll do the same. Project tool here, there, 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 and there. Just like that. And up to the top. Same thing on this side. Extrude, remove, through all, there. Just like that. Now we'll hit the fillet tool. 1/8 of an inch fillet seems fair. Just like that, make it look nice. All the way around. Green check mark. We'll hide that sketch, and just like that, we have our top cap integrated into our clamp. I've been doing this sort of CAD stuff for quite a few years now. I've had a lot of experience with a lot of other softwares. Onshape truly is a game changer. It's super fast, it's super easy. I'd recommend it to anyone. It's a fantastic program. If you're a professional or want to try it out, you can get professional Onshape access for up to 6 months. We're back. We got the top cap integrated into the part. We only have 2 parts now. We're hoping it's a little bit stronger. We're gonna put it back on the vise, send the impact to it, and see what happens. I'm hoping it'll be a little bit stronger. I think probably the bottom one will give out before the top one, but they might kind of go around.
Strip, bud?
Yeah, I think so. You might have to give her a little touch with the impact.
All right. Good to go?
Yeah, give her. Go evenly. Oh yeah, so they're cracked, but still nice and strong. Still holding steady.
Yeah.
Didn't explode like the last one, so that's definitely a positive.
It did hold up a lot better.
Give her. Oh, there she goes. Finally. All right, let's take it apart and see what happened.
Do the other
underneath
side.
there.
Break her
Yeah,
fully.
keep going. You're right. Alrighty, so we are here. We broke it. We figured out the flaws. We went in Onshape. We fixed it, and we tested it again in no time. We really couldn't do it without Onshape. It's a fantastic tool.
Okay, this is exciting. If you look behind me here, we've got the batteries installed. We've got our high voltage lines run. Now comes a critical component, connecting the batteries to the high voltage system. Everything's plugged in. This is probably one of the most critical things. I know we joke around a lot here. We have a lot of fun. One thing we don't joke around with is when it comes to high voltage safety. There's not much on a normal truck short of dropping a transmission on your head that can kill you. High voltage lines can kill and seriously injure. You need to know what you're doing.
We have taped off the whole area. This keeps people out of our zone. And by doing this, we can say anyone who's in our high voltage zone is briefed on our tests and our test plan and can work with us, and everybody else stays out. So we have our whole zone around the truck, and we even have a high voltage safety topper, even though it's quite redundant.
Well, those guys are working on the programming and the fault codes. The bodybuilder that's going to be putting the rig up onto this sent us the dimensions for the frame rail, so we're just cutting the back section of the frame rail, shortening it ready so that when it gets to the customer's end, they can drop their body and their chassis on and it'll be ready to go. And once we did that, one of the last things we got to do is put the differential oil in. If we're getting ready to spin the axles, this is exciting. We got to make sure that those differentials topped up with oil.
Conrad right now, he's just communicating with all the parts on the truck. He's seeing what their states are, what they're reporting, making sure we're getting everything we expect. Once we're done going through that, wheel spin is ready to go.
We are working on axle spin. We have the PDU charge, we have high voltage run, we have low voltage run, we have communications between axle controllers, our control board, computers. Everything is communicating. We are working on resolving 4 faults right now that are probably, hopefully related to us not sending any requests from the axles.
So we've got oil in the differentials. The high voltage team has gone over their safety procedures, their checklist. Last thing to do is start sending power back to these things and see if we can get one to spin.
I'm sending the applying.
Errors when you send that message.
That's just what they call it. Okay, manual shift permission.
You can hear a bit of the whining of the inverters.
For some reason, I have lost connection. If now that the MC is on,
Pulled a bit more aggressive that time.
It is coming out.
We actually got the axles to spin.
We need to figure out how to make them not spin.